Howdy darlings, how are we doing? Today I wanted to talk about upgrading the GPD Win 2's cooling solution. I think it's something that's absolutely necessary. I can see why GPD did what they did when they were designing the heatsink, but I think there is a absolute massive amount of potential. And so I've been creating a couple prototypes of something that in the future might become reality. This is one of them. I have my GPD one assembled right now, but I have a stock heatsink in here, liquid metal, and then what I actually do, and a lot of people don't know this, is the actual fan housing, the actual housing for the fan, while the side's plastic, the bottom, like this is kind of mirrored on the bottom but filled in. This shroud is actually, I'm not sure if it's aluminum or just like cut steel, plate steel. But what I do then is I liquid metal the CPU in the bottom of the heatsink, and then underneath the fan, but between the heatsink, I actually apply thermal paste. And so there's like a big divot under here, and then you can connect basically the CPU to the bottom of the fan. And obviously with the fan blowing cold air in, it's going to cool that plate down, and then it's going to push some of that heat out. Now of course it's not textured at all or anything, so it's just like blowing air on just basically bare copper or bare steel or whatever, but still I think it does provide an improvement. So the stock heatsink, if you're not aware, is basically just like this big copper plate. There you go, you can kind of see it there. And there's none of this, none of these heat fins. These are all aftermarket, something I added on my own. It's just this little bonded fin assembly, and then the fan. That's it. There's nothing on the side. It's just bare copper. And if you flip it over, you realize that there's a whole bunch of space that's just completely unused on this heatsink. I think about everything here over is completely bare, and then here over, about right where the edge of that tape paint stuff goes, this is all just bare. So if you take out the area where the screws go in, you have actually a massive amount of space that's completely unused. So what I decided to do is I went on eBay and I bought a couple of these like super small form factor like HP Envy heatsinks. And then they go like this. This is where the CPU would be, and then it had a bunch of these bonded fins all the way across here. And so what I just did is I took a heat gun and I pulled them apart. You get the big heat fin assembly like this. Now, when I originally did this, I was aware of one thing. I was aware of the Z height of the device. So you can see like the fan is about where the plastic begins. There's a little grommet in between. This one doesn't have it for some reason, but usually there's a grommet between the top of the fan and the actual ABS material. And so I figured, okay, one of the restraints that I have is the height. So I grinded them down. That's why they look like crap. But when I started, they looked like this. Actually look very nice. And then I had to drill it where the screws are, and I didn't really know any way to do that because these are all bonded together, which means that the top of these fins, let me see here, the top of these fins are actually like interwoven. You can see that on, oh come on. You can see on the side how like these little fingers are sticking out, and they go into the next little plate, and then they're just pressed together like that. So they're actually not easy to get out, especially from a middle perspective. And so first off, you have viewing this side up, so this way, viewing this side just like this, if you didn't have this plastic on here. You have a couple restraints. You have the bottom section of where the analog stick is here. That's where that little cutout is. There's a big, huge, what am I thinking of? There's a big, huge washer that goes around here, and that's why I decided to remove so many fins. And then about the same size as that it's cut out here of these fins is where the actual analog stick pops up a little bit. And then I had to cut these fins here because this part at the edge, there's actually two things here. First, there's a fan connector, goes like this, like up there. And then this is something I didn't see until I installed it. There's actually a bunch of pogo pins about right here where the actual trigger button for the right, I don't even know what this would be, R3 or L3 or what is this? L2, just kidding. L2 would go right here. There's a couple pads on the PCB, and then the pins just connect there, and those were here originally, so I had to cut them out. So I decided I'll screw it, I'll just take this whole section out. So it looked like this on the other side. It actually looked really cool when I first did it. But then I realized, oh crap, I have to grind it all out because it wouldn't fit physically in Z-height terms. It was too tall. And then another problem I ran into was when you have this installed, one second here, let me move these. When you have the heatsink installed, basically what ends up happening is it's in the same orientation as this. Let me line it up. Screws right there. That's about right. Yeah, that's about right. And so what actually happens is you can see, where's my finger? There it is. So you can see this is kind of where the pins come down right into here. The fan connector up here, the exhaust is stock. You have the USB header right here, which actually everything, I lined it up pretty much perfectly when I soldered all these fins in. And then the SSD's right here, and it lined up pretty much perfectly. But the problem was, and this is a huge problem, I did not realize this from the beginning, was that the ABS material is not flat underneath here. The actual underside of this ABS plastic is not flat in this area and in this area. And that caused a huge problem. That's why this ended up being a failed design, is because the actual SSD around where this outline is, it's actually encased in ABS material. So like the SSD, once you open this door, it slides in, but it's got a wall on this side, a wall on this side, and some on the bottom, and then the connector pokes through over here. And so what actually happens is all the tips of these actually end up running into ABS material. And not only that, there's actually ABS like structural bracing along here that's, I don't know exactly to measure it out yet, but it's probably half the height of these. So when you press down in these areas, it actually doesn't flex at all. And that's why, because there's actually bracing material. There's actually structural shapes in here that hold it to be very structurally sound. And it is. It's a really well-built device. You can see that when they molded it, if you flip this over. I was just doing some testing, so that's why I don't have it taken apart right now. So, yeah, this is actually a really good idea, and I'm actually kind of happy with the way it panned out. It looks like crap. Didn't look like crap when I first did it. It actually looked just like the top. It was all painted and looked really cool, but then I was like, oh shit, I gotta cut out the holes for the screws, and then I had to grind it down to make it fit, and, then I had to come up and fix this problem over here because it wouldn't physically fit inside. Now it fits. Now it works, but I can't get the plastic on, and I can't really validate any performance results because if you don't have the plastic on, the bottom, for whatever reason, the performance seems to be really poor. And I think it has something to do with the way that the plastic and the grommet that this one doesn't have, there's like a rubber grommet on the top of this, directs the flow of air. And I don't have any of that, so it didn't work very well. I mean, it worked fine, but the performance was nowhere near what I was expecting, which shouldn't make any sense at all. Now, another thing that I was thinking of is maybe I can just cut the fan housing on the side and have it blow air this way and that way, a lot like a lot of higher-end gaming laptops or performance laptops have. So, yeah, that's that. So I'm probably just going to remove all these fins, return it to stock. It worked just fine. My next thing I'm going to look at is using these. These are like these little aluminum fins, and if you compare the height, I don't know how I'm going to do this, let me just try it like this. If you compare the height, they're pretty much the same, a little smaller maybe, but they're not as wide, so maybe I'll try to get these on there instead, and because I could probably, maybe these are a little bit bigger than I thought. Yeah, something like that, but around here, and maybe pull them out, over this way, like here, and then a couple here. Cut the side of this fan housing out so the air blows that way and that way. That'd be pretty cool. I think that might work, and I think I might be able to match the inlets where the cutouts are to the actual ABS material because it's actually pretty small. It's not like a big block of ABS, but it's just like these little like parts about the same size as these fingers that stick out that just come down like this on the bottom of the material. So I might be able to, you know, kind of mate those together and get that to work. That'd be really cool if I could actually do that. So that's that. And then I have some other stuff here. A couple ideas I have is maybe trying to integrate some sort of heat pipe. This one's way too big, but just an example. These are what the heat fin assemblies originally look like. As you can see, like I was saying, they're really nice looking. They're like all bonded and colored and stuff. So it looked really cool when I first did it. And then this is just from the original heatsink. So yeah, that's where I am right now. Plans are definitely there. This is a prototype of a prototype, basically, and I'm not really sure where I'm going to end up going with this. There's a lot of potential here for cooling. I'd like to deal with the fan as well. My current plan is to, once I get the heatsink done, I'm going to hijack the PWM signal, dump it into a like Raspberry, or not a Raspberry Pi, a Arduino Nano or some sort of super small SBC, you know, something super tiny, and then I'm going to put a thermistor on here, bond it to the heatsink, and then just completely get rid of the CPU's thermal controls for the embedded controller because it's always on. They're kind of garbage because the active and passive trip points don't work. And then I'll just be able to set it based on the custom heat fan curve that I make and based on the temperature of the thermistor on the CPU. So that's where I am right now. We'll see where it goes. I hope that these will end up being fruitful and I'll be able to get some really solid measurements off these, because if these pan out, I want to kind of actually aim for a real production model or a real prototype, and actually have the heatsink not be copper and actually install a vapor chamber. And then I'll actually have, you know, like these bonded fins maybe here. I don't know if I'll make them all the way around because I still have to run into that issue of the chassis plastic. But, you know, something might work from that. So that's the goal right now. That's the plan. We'll see how it holds up, and we'll see where we end up in, you know, probably the next week or so as I get time to keep doing stuff like this. Oh, another thing I want to make known. So I made a video of thermal shutdown. I encountered an interesting phenomenon when there is thermal saturation on the device for a long period of time. What actually ends up happening is it starts to creep out into the ground plane from what I've seen. So the CPU doesn't just get hot, the CE sync doesn't get hot, but when it's above about 85 to 90 degrees Celsius in that really high-end 15 watt plus range TDP, it starts to heat soak the motherboard as well. And what I think actually ends up happening is the MOSFETs, I think they're about over here, they're over here, whatever the hell they are. Yeah, I think the choke's over here. So yeah, the MOSFETs, I think they actually get heat soaked from that in addition to their own heat, because I don't think they're actually designed for, you know, 20, 15 watt, 25 watt, you know, power. And I actually think they get heat soaked, and I think that also contributes to some of the thermal shutdown problems. So I'm going to be doing some stuff with that as well, trying to fix those, because just getting some probably thermal pads will, you know, probably fix that problem as well. Anyways, this video is way longer than I expected. But yeah, you guys got to kind of see what I was thinking of. So lots more stuff in the future. I may do a video of, like I said, liquid metal that I'm very happy and actually kind of stunned, not only with the performance is really good, but the characteristics of actually installing liquid metal actually influences the way that the temperature curve works and actually some of the power delivery stuff as well. And I'll explain that maybe in a different video. But, you know, like it if you liked it, dislike it if you disliked it. Sorry if you disliked it. But, you know, that's about it. I hope you all have a wonderful day, and I'll be seeing you in the next one.